Hello and welcome to this video on solubility product. My name is Kim, and in this video we'll be going through the steps for writing a KSP expression for a dissolution reaction. Dissolution describes the process of dissolving a solid into a liquid, usually water. For example, my hypothetical solid AB is added to some water, and after I've let it equilibrate, a proportion of the salt will dissociate into its ions A+ and B-. The KSP will describe how much of the salt will dissolve in solution at equilibrium. All K constants are defined by the ratio of the concentration of the products over the concentration of the reactant. Notice that solid AB doesn't really change after dissolution. The types of salts described by KSP expressions are going to be sparingly soluble, and so the solid will not have a noticeable change in concentration. Therefore, for KSP, the reactant in the dissolution reaction will not appear in the expression. So for the general balanced reaction AB, KSP will be described by the concentration of the products only, raised to their stoichiometric coefficient as described here. With this review, let's tackle the applied questions. The applied questions ask you to write the KSP expressions for the following reactions. In part A, potassium chloride dissolves into potassium ions and chloride ions all in a 1:1:1 ratio. KSP will exclude the solid potassium chloride, so will equal the concentration of the potassium ion multiplied by the concentration of the chloride ion. Part B asks for the KSP expression of calcium hydroxide. For every 1 molecule of calcium hydroxide, 1 molecule of calcium ion and 2 molecules of hydroxide ions are produced. The KSP expression equals the concentration of the calcium ion multiplied by the concentration of the hydroxide ion to the second power to reflect the stoichiometric coefficient in front of the hydroxide. In part C, calcium phosphate is dissolved into calcium ions and phosphate ions. Be careful here. Notice that the reaction isn't balanced. For every 1 molecule of calcium phosphate, 3 molecules of calcium ions and 2 molecules of phosphate ions are produced. You should never assume that the equations are balanced when given. Always recheck that stoichiometry. The KSP will equal the concentration of calcium ions to the third power and phosphate ions to the second power. Writing out KSP expressions will lay the foundation for future steps involving calculations, so make sure you're able to do this for any dissolution reaction. Definitely follow this video up with some practice.